Awesome. Okay, great. So thanks for having me. You see my face here. My name is Simon. I'm the VP of product at e-commerce at Coveo. We're about 800. I have a few slides on that. I'm going to talk about the catalog and the vector space, mostly the science under that, because there's a lot of talk nowadays about vector database, vector search, as well as LLM more and more. So I want to chat a little bit about the science behind it, what it's actually used for. Obviously, in 25 minutes or so, I don't have time to go deep into the science, the A/B testing, the comparison in between the different approaches. I just want to, tell you a little bit what it actually does. Plus, since this is, a bit of a more of a product show, I want to talk also about the product organization. That being said, again, I only have about 20-25 minutes, so I might have to rush a little bit at the end. We'll see how it goes. So quick word about Coveo. We are an AI company at our core. So we offer everything around AI product discovery and content discovery. So mostly we do search for commerce, service, and workplace. And we've been pretty much all of our customers in one way or another use our AI powered features. So we're not, AI is not kind of a side thing that we do at Coveo. It's really the core of it all, and the entire product gravitates around it. So we kind of usually know our stuff around that. On the e-commerce front, so the product that I personally control, which is about, about half of the company, is e-commerce product discovery, so search, listings, and recommendations. And last slide about Coveo, and then I'll get to the meat of the stuff. We're headquartered in Quebec City, Canada, about 750 employees, 300 in R&D. So you can account for, around 60 to 100, depending, close or far from e-commerce. So quite an important engineering organization, not the biggest, but not the smallest. And you can see on the right side, 1,000 ML models served daily. So we're into AI quite deep. We are hiring, so we have a few things here. I'm gonna have that slide at the very end, so no need to rush. But just saying, at the very start, we are hiring. So now, in the meat of it all, so detecting intent. So the entire thing about vector-based, the entire thing about taking products out of e-commerce and putting them into a vector position inside of a vector map is all about detecting intent. So in this image here, for example, I'm able to know that this kid has somewhat of an interest in going up the stairs, whether it's because he's looking at the stairs, the direction of his feet, or even just the fact that there's a kind of natural pathway, from the ground to the stairsway and everything. But in the kind of online, in the online journeys of shoppers, this is not always easy to kind of detect. So you're not entirely sure when someone is browsing where they are actually going. Are they in the buying journey? Are they in the discovery journey? This is the kind of thing that, so far for the last 20, 25, almost 30 years of online e-commerce, or e-commerce by the name, has been kind of a challenge to kind of do journey mapping in ways. And this is where vector-based and product embeddings kind of help. So at the core of it all, and here this is a slide I took from Adam Ormsby on Twitter, because it was actually pretty accurate. The entire thing is about keeping the data and the journey and the experience of the shoppers inside of products. So if you look at two products here, so cat food, dog food, you have the typical question, which is, how similar are these two products? What are the similarity or complementarity between these two products, the cat food and dog food? And if you use what we call one-hot encoding, traditional AI method using big data, you will find not really a strong relationship between cat food, dog food, or even a third product, which is a banana. So if, for example, I look at all of the journeys using big data, I look at all of the journeys of my cat shopper or my cat food shopper, and all of the journeys of my dog food shoppers, I will find that they are somewhat looking at similar products. However, I do not know that there are similar products because the amount of journeys that will actually buy the two type of food, cat and dogs, will probably be quite small in the entire data set that I have that will really favor, cat food buyer, dog food buyers and whatnot, meaning that I cannot find intrinsic relationship between these two different products, meaning that if I have, for example, much more dog food buyers for any reasons, I cannot necessarily take this assumption or that learning that I got on Dog Food Lover by kind of translating it or sending it on my cat food data. Meaning that, I will never learn from one to the other. Meaning that if I have, a third product, grocery product, in this case, banana, it has pretty much the same similarity in my eyes when I just analyze big data as dog food and cat food as to one each other. Which is somewhat sad because there is a relationship between these two products. For example, if I buy cat food, there's a good chance that I'll buy, cat accessories. I'll buy toys for my cats, and it's pretty much the same kind of journey I'll have with dogs. Because in the end, these two are food for animals, while banana is something completely different. It's food for humans, but also it's a grocery item, which usually comes in a completely different type of shopping journey. So at the core, what started to happen, in the year 2010, moving forward, especially a lot of it came out of Google at the time with Word2Vec and BERT, was that people started to add data instead of adding them into journeys. They started to add them into words, meaning that if I take, for example, blueberries, it has a certain definition. It is not only their description or the category they belong to, but there is a certain usage. People buy blueberry um, when they buy, a range of fruits. So they usually buy it with other fruits or other fresh product. They will buy blueberry if they want to do a blueberry pie, for example. So if a blueberry is followed by, pie ingredients, there's a good chance that, there's a recipe happening there. But they started to do that really with words. And what on our side we have done, and not just in this case Coveo, it was actually a joint initiative with several university and other companies, what we call product embeddings, meaning that you actually keep that behavioral data inside of the product themselves, meaning that, this Nike Essential here, for example, they could be used mostly for runnings or for basketball without necessarily being categorized that way. They could be used for running, but only in certain situations. They could be bought by a certain type of person that usually buys other product similar to it. So we're kind of augmenting what we know about this product, what comes with it outside of, a commerce engine or a PIM, for example, the description and the name, and we augment it with behavioral data. What this allows us to do then is to create what we call obviously a vector space. So mostly a 3D representation of the catalog that contains these products somewhat augmented. And all of the different clusters of colors that you see there in the visualization are actually categories of product, again, categorized with their behavioral data or what people actually use them for. So this creates kind of a parallel representation of a typical catalog, which is categorized by usage instead of being categorized by category or brand or what you typically use to filter on product. And then when shoppers starts to appear, when they start to go on your site, they become what we call user session vector. It's a little bit diminutive in a way, but that's what they become. So they become a kind of little dot that will navigate through that space. And then when we start to see, the position of that vector, that user session vector, we're trying to figure out, in which cluster they are and where they are most willing to go. So this is somewhat similar to someone that walks in a store. They will have, kind of cues. They will look at the sign up to see which aisles they're in. They might show a little bit of, in their face, you might see that they're looking for something. They might ask you a question as a store associate, which would be the equivalent to a search in the e-commerce scenario. So you start having these kind of tips that will tell you, where that user is and what's most likely to happen in the future. So when you're looking at words, you have, this simple example here from Bert, which is she is running a company or a race. So you have someone, a she, who's running, a company or a race. You don't have the end of that sentence. You're not necessarily sure what she is running. But if you know that there's a context after it. So she's running a something and she expects to win, there's a good chance there's a race there. So if we look, for example, at the word bank there at the bottom, we went to the river bank, or I need to go to the bank to make a deposit. So if we realize that, we're missing a word, which is, the missing product in the e-commerce sphere, we'll look at what's happening before, what's happening after, and we're able to figure out what was the missing product there and then recommend it on the next time. It also allows us to detect, if the intent's right. So if we realize that, the user's browsing through items that are somewhat kind of familiar with the same usage, we understand here you can see the green bars here are distance. So they are actual distance in between 2 points in the vector map. But if you see, that they're looking at products that are completely different, sometimes changing, in their usage or even in the type of person or even in their sizes in the case of shoes, which makes you realize that there's probably, other members of the family there. Maybe it's a gift, but in all cases, we don't necessarily know what is the intent there, what they're willing to, what they're trying to do, what they're trying to shop for. And then we avoid, that situation with typical big data recommendation, which became somewhat viral around Amazon, which was you're buying a toilet bowl, and for 5 years, after that purchase, you're being recommended the same kind of toilet bowl pretty much every time you go to a session, because the only thing that they know about you was your past purchase, but they don't necessarily try to reassociate your intent with the new journey that you have. So this allows us to say, within a few clicks, well, they might not be interested in that product anymore and simply cancel the overall journey. And obviously we use that, in our case, we use that for search, for recommendation. In this case, query suggestion using just two letters here. So GR and GR, one in a camping journey, the other one in a more fishing journey. And you can see, the results that are different. So this is really the way that we use it for a customer at Coveo. And the way that it's used somewhat in real life. So it's to do that one-to-one personalization, anonymous into session in a commerce scenario. Some additional papers, if you're interested into the science behind, BERT, behind dense embedding, behind vector space. Two interesting paper here that was released again in collaboration between Coveo and other companies or university. Bird Goes Shopping or Shopping in the Multiverse. You can just Google them. Could have added a link, but you cannot really click the links. But yeah, so just search for them. Really interesting if you're more into the science of it. Now, the other thing that this allows us to do is to understand also what are products that actually have no behavior, which has always been a problem overall. When I mentioned that example with Amazon with the toilet bowl and such, it might, this could happen a lot if most of your purchase on Amazon happen on products that are not that popular. There's millions and millions of products. I wonder if they're almost close to a billion now, millions of products on Amazon. And, maybe 20, 30 maximum percent of them are really, looked at in a kind of repeated manner. And what we're seeing for most of our customers, most of the people actually in the commerce space, is that around 30% of a catalog is composed of warm items, meaning items that are clicked often, that are viewed often, that are purchased often. The rest of the time, it's cold products, and then you get frozen products, which sometimes are just new items. And the reason why this happened is, usually as a retailer, you have some sort of a specialty. So your specialty item will end up in the warm item most of the time. But also, it's kind of fortunately, a consequence of the promotions on retail sites. So most of the traditional promotion strategies have been about, pushing certain products, trying to sell, products that you have on high inventory or you have a certain margin on it. And this leaves that, you cannot make as much noise as you have items in your catalog. There is a point at one point where, you have items that you cannot promote all the time, especially if you go, into groceries or a pharmacy, like a drugstore. It's hard to promote, every single item and avoid cold item. So what vector embeddings allows us, and not just us at Coveo, but overall in the search and even the recommendation sphere, is to create, is to try to solve that long-term problem. So, I take the typical example here, 200,000 products, 60% of these products with less than 10 visits a month, 10% with no visit at all, meaning frozen. So dense vector created for about 30% of the catalog. By dense vector, I mean products that we have knowledge about are about 30% of the catalog. So we've released yet here paper, if you're interested, called The Embeddings That Came from the Cold, Improving Vector for New and Rare Products. So this was a paper that we released about 2 years ago about the idea of long tail hypothesis. And what it does mostly is that we will take the knowledge that is kept inside of the product itself, instead of being just big data of journeys that stays in the database somewhere. It's actually product that is stored, data that is stored in the product. And we will make an assumption on products that look somewhat similar, whether through images, metadata, description, so anything that we can extract from the product and see products that are somewhat similar, and then push the knowledge that we have on product A towards product B, creating an embedding on that product. And so far, with some of our customers, we've seen, an increase in catalog coverage to about 99%. We'll say 100%, but there's always new product coming in, so keep it at 99%, which means that now these products, when I click on them, when I purchase them, we can make an assumption on the current journey of the user through those products. And also we can re-rank them accordingly, meaning if you have a new product coming in, we will be able to recommend it even if we have little knowledge about it, just by making this assumption. And by augmenting these products this way, this leads us to the last part, which, I would have liked to say I will not talk about ChatGPT, but unfortunately it is unavoidable in the current, state of the market. So, if you take the example of GPT, which is powered by LLM, large language model underneath, it is all about extracting information and generating details and description of products, in our case, in commerce, of products, but also, text or even code now more recently. But what happened though is that there is a concern that, the content that is produced might not necessarily always fit what's inside of your catalog, and sometimes might be explained in ways that are not completely related to the content of your catalog. Again, might not necessarily fit your own categorization, or even fit your, the brand that you store in your catalog and whatnot. So, if I ask, for example, here, what are the best paddle boards for beginner, I'll get this kind of generated answer through generative AI. Which say, a good paddle board will have wider dimension, more stability, a soft cushion top, for example, and also even a link for, entry-level touring paddle board if you want to do more touring. But when then you want to extract the products that are related to that, you need to have these kind of facets here at the top here: paddleboard, high stability, soft top, wide. So you want to make sure that the content that is written in the text that has been generated is related to the content that you have in your catalog. But if these facets, these attributes, these product attributes don't exist in your catalog today, you need to actually create them. So whether you're manually, create additional attributes in your catalog, which is a near impossible mission for most retailer, or you will use product embeddings and vectors and product embeddings to augment the product with what we've learned from the users. So if we have a lot of users that have looked, at these products by searching, high stability paddleboard or something like this, and ended up selecting certain products, we can associate the idea of high stability or soft top to these products and then preserve it, even if they haven't been tagged that way. So this is one of the best way to attach a normal search index, a normal product catalog, which has a certain set of attributes, with generative AI, which does not necessarily respect the attributes that you have in your catalog. So to augment the catalog so that it becomes kind of useful for a Gen AI situation. That is more future consideration, but it is an interesting end for a vector-based product. And then finally, because so that was really the science behind it, explained in 15, 20 minutes. And unfortunately, I leave the paper there if you guys want to read about it, but unfortunately, I don't have more time to dive deeper into it. But I can talk a little bit about the team. So, as I said before, Coveo is around 300 plus developers. It is a massive cloud SaaS platform, one of the biggest consumer of a certain cloud provider, which I will not name, but we are one of the biggest consumer in Canada. And obviously, the platform itself contains a lot of components to it. And when you look at all of these components, they translate to teams, meaning that, the commerce team, which I oversee directly, is just a small part of that entire machine that is, Coveo R&D. So you have the AI team there, obviously, which is massive to create everything, all the research around vector, around LLMs, around big data overall. And you have even an AI infrastructure team that will support this. So as a commerce product lead, which I oversee about five product manager plus a team of product designers. If I want to put a certain emphasis, or I want to put a priority around a specific feature around commerce, they have to manage the relationship in between these different teams. And as the previous speaker mentioned, you can improve the agility, you can improve the efficiency within a certain team, but when you actually have multiple teams working with each other and interacting with each other, that's where complexity really rises. And then obviously, I'm not even talking about the SaaS cloud platform underneath that supports it all. So one thing that we did, and the 2 minutes on that, is we decided to use team topologies. It's one framework. I'm not saying it's the best. It's just the one that we use. If you're interested, you can search for them. And here, I added a few important elements of team topology, which is first of all defining what are your different teams and how are they, structured. What is their topology? And there are lots of other steps. I will skip a few. Also defining what is the interaction models in between these different teams. So, if I do the topology here of my different teams, meaning that, for example, the data platform team is what we call a platform team, obviously comes with the name. The search team, which manage the entire query pipelining, is a complex subsystem team, meaning it's a team that can barely be work with. It's a very complex environment that they evolve in. And then you have, for example, the commerce team, which is what we call a stream aligned team, meaning it's a team that is supposed to be full of full stack developer, which are able to ship things from A to Z to our customers. So they should be empowered by all of the other team. And then you define your interaction models here, meaning, for example, the DX team, which is the developer experience team, which will collaborate with the commerce team, facilitate the commerce team. The usage analytics team will offer an X as a service so that we can push and extract data. The AI team will work in collaboration to build machine learning model. Same for the search team. And this, what it does is that it reduces the cognitive load on the commerce team while they are still able to completely serve from A to Z our customer from inception all the way to user testing, and then going into production and even creating documentation and training. So obviously, it means that the commerce team has just a few missions. So getting data in, communicating with merchandisers, so building merchandising tooling, and then serving search through services that exist under the hood. And here, if I say getting data in, it means creating branded connection, for example, to Salesforce, SAP, Commerce Tools, Shopify, whatever you call it. Maintaining a certain tracking protocol that will reach all the way to the usage analytics team, which provides a service for that. Standardizing and streaming data to AI, so working with the AI team directly. And then things that are not necessarily, part of R&D, but are somewhat part of the pod in a way, creating and maintaining partner documentation, working with third-party vendor and such. And you have the exact same kind of sets of tasks with, communicating with the merchandising, and then even serving search recommendation listing and badging, including the ownership of AI feature. Although the commerce team is not the AI team, because they are empowered to use AI feature and to build AI model through services, through collaboration, they're able to fully own that kind of AI journey, even though they are not data or scientists themselves. And then on that, it allows us to create what we call our product flywheel, meaning that every single team inside the commerce organization will be part of that flywheel. So I will have an implement team that create connection, maintain the tracking protocol, and get pretty much customer on board. Engage team, which will offer merchandising tooling for the merchant to play with their AI model, tune them, use them, A/B test them. Then the analyze team that will offer report and insights, and then the diversify team, which will think and develop new models with AI. And all of this with one goal in mind, one North Star metric, which is the increase in RPV. So that was a very quick overview of the organization of Coveo, of my team specifically. So a product organization around an AI product, and obviously the AI itself, which is the vector space. So if you're interested in whether what we do or how we do it, both are good. You can reach out to me directly, Simon Langevin on LinkedIn. I forgot to add my name here, or you can apply talent at coveo.com if you're interested.